Hello everyone, we're from Team 2 and today we're going to show you our practicum about the rate of reactions. The speed of reaction rate can be controlled because there are several factors that influence it. Now in this first practicum, we are going to show you that the reaction rate can be controlled by the concentration of the reactant. But before starting, we have to pick the tools that we need for this practicum, and then we have to wash it and clean it until it's dry with tissues. As you can see here, our friend Miftah is getting a magnesium ribbon from our teacher, and this is how magnesium ribbon looks like. So with that magnesium ribbon, we are going to cut it up to 3 pieces with a length of 5 centimeters, and then we're going to scrape it with sandpaper so we can make sure that it is smooth. And this is me measuring the hydrogen chloride for about 10 millis. And this hydrogen chloride is with the concentration of 1 mol. And after that, I am putting the hydrogen chloride inside the reaction tube. Okay, so for the first tube is done. We have poured the hydrogen chloride with the concentration of 1 m. And for the second tube, we are needing the hydrogen chloride with the concentration of 2 m. And for the third tube, we are going to need the hydrogen chloride with the concentration of 3 m. Next, we are going to set our timer and put the magnesium ribbon inside of the hydrogen chloride with the concentration of 1. And then we are going to wait until the magnesium ribbon stops reacting, and we have to see how long does it takes for it to stop reacts. And we are going to repeat the same process for the second tube and the third tube. So from this first practicum, we can make a conclusion that the higher the concentration is, then the rate of reaction is going to be faster. Now we are going to continue with the second practicum, is that reaction rate is affected by the surface of the reactant. Firstly, we need 3 test tubes, and each of the test tube is going to be filled with a different form of calcium carbonate. The first tube is going to be filled with calcium carbonate in powder form, and the second one is in granules form, and the third one is in chunks form, and each of them has to weigh around 1 gram. As you can see here, I am carefully separating the powder, the granule, and the chunks of the calcium carbonate so it doesn't mix up. And next, we are going to measure the hydrogen chloride and make sure that it is 10 milliliters to be exact. After that, we are going to put the hydrogen chloride inside the calcium carbonate in powder form. Don't forget to set the timer so that we know how long does it takes for it to react, and we're going to stop the timer when it stops reacts and see how long does it takes. We are going to do the same process for the second tube and the third tube. So from the second practicum, we can make a conclusion that the wider the surface of reactant is, then the longer the reaction will be. And for the third practicum, which is the last practicum, we are going to show you that the reaction of a chemical is also affected by the temperature of the chemical. Of course, the first step is to pick the tools we need, and then we have to wash it and clean it until it's dry with a tissue. And here I am measuring the sodium thiosulfate for about 20 milliliters. We also have to measure the hydrogen chloride for about 2 milliliters. After that, we have to check the room temperature, and at that time the room temperature was 26 degrees Celsius. There's also a process we forgot to record, and that is making an X on top of a piece of paper. So the function of the paper is to see how long does it take for the chemicals to cover the X sign. So we're going to put the tube with the sodium triphosphate on top of the X sign, and we're going to put the hydrogen chloride and wait until it covers the X sign, and don't forget to set the timer. We're going to repeat the process, but on the second time we are doing this differently. The hydrogen chloride has to be heated, and it has to be heated until it is 36 Celsius degrees. After it is 36 Celsius degrees, we're going to turn off the fire and put the hydrogen chloride onto the sodium thiophosphate. Also, don't forget to set the timer so you can see how long does it take to cover the X sign. And for this third tube, it's going to be a bit different from the second one. We're going to lit the fire up into the spiritus lamp, and we're going to heat it for about 46 Celsius degrees. And just like before, after the hydrogen chloride is 46 degrees Celsius, we're going to turn off the fire, and then we're going to put it inside the sodium thiophosphate. So the conclusion for this third practicum is the higher the temperature is, then the rate of the reaction is going to be faster. That's it from us. Thank you and goodbye.